Here we will discuss about Excel. For our first lesson, we'll talk about using formulas and functions in Microsoft Excel. To give you an overview what Excel is used for, well, in many ways it has helped many business operations because in Excel we can do specific calculations, we can organize and manage information, we can also visualize data and build our reports and dashboards. Reports and dashboards in Excel are summarized version of your information or your data set. In this example, this is a report, sales report, where our data is summarized per quarter. So this is the product and this is the sales amount per quarter, right? Well, a dashboard is a more dynamic version of your report because you can actually filter out things in dashboard and it's pretty much self-service. Other people can cut information in dashboard as they wish. You can also include visualization in both dashboards and reports. Visuals are a good representation of your data as well, and it can give you a picture of how your information looks like on the onset. So moving forward, we will try to create reports and dashboards in Excel as well. Okay, now let's navigate through Excel. When you open Excel, this is what you will see. This is like our canvas. So this is where we will update information. This is where we'll type things. The box with the green border is called the active cell. So once it's active, you can type words here, and that's just how you update data in Excel. Okay, our convention in Excel, these letters, vertically, these are our columns, and the horizontal spaces are your rows. And the way we call our active cell would be in form of our column name, our column letter, and our row number. Okay, so this one is A1. This is our first column and first row. Well, this one is A2. That's our first column, second row. If we move here, this is B2. That's second column, second row. You can see the cell name here. Okay. Now this is our formula bar. You can also type things here and it will be updated in your active cell as well. So if I type something here in the formula bar, as you can see, it gets updated in the cell as well. Okay, now here you can see there are names of these are called sheets and tabs. So this one is sheet 4, the one that we are working on. You can also add another working sheet here by clicking that plus sign there, and you can name it. Do right click and then rename sheet. And now we have another working sheet. Okay, now moving forward to this part, this is our ribbon section, ribbons and button section. So now we are currently in the home tab. This is where we update fonts, alignments, number formatting, and styles of our cells. Okay, so going back here, we can update font sizes here. We can update alignments here in this area, and then the number formatting here. We can also insert other elements, not necessarily in your Excel file. Let's say you have another information from outside, you can do it by inserting here. Okay, you can also add pictures using this button or shapes. In this tab, this is more for the printing part. So you can adjust your margins, your canvas size, your print area here. For this one, this is an important tool in Excel because here, this is where we refer to our calculations. So if we want to do mathematical computations, you can do it here by using these buttons. This is our reference for the functions that we have in Excel. So we have financial functions, we have logical functions, we also have some text functions for cleaning your data here, and many others. Now this tab, the data tab, this is where we manage our data. If, for example, you have databases outside of this file, you can manage it here. So you can refresh also your information here. You can connect to other sources here. You can sort your data. You can filter your data in this part. And you can also clean your data here. This one is more for reviewing your file. So you can also add comments. You can check the spelling here. And you can also protect your sheets and your workbook. You can put passwords here. For example, you have confidential information, you can do it here by protecting your sheets. Okay, so this one is more for navigating. If, for example, you have big tables here and you want to freeze some parts, because if you scroll down, you won't see the top part. You can freeze it here and freeze some parts here. Okay, now let's try to see how some buttons work. There is a sample um, text sheet in this file, so you can follow through by clicking the buttons as well. So we can change our font. For this example, we can change our font using this under the Home tab. We change it here. Let's say change the font and the font size. We can also bold our text, or we can italicize. We can also underline. We can also fill in color. We can try to change the font color. These three are for vertical alignment. So you can see we can click this for making the text on top of your cell, right? Well, for this one, we can keep it at the middle. This one, we can put it at the bottom of our cell. These are horizontal alignments. So, for example, aligning left, we keep it that way. Align center will place your text in the middle of your active cell, and this one for aligning your text to the right. This is for merging cells. So now we have one active cell. We can merge this and this together and make it only one active cell by clicking this merge cells. So if you can see now, it's B14 and C14 is now merged into one. Okay, we can also do formatting here. So we can click this and format our number. We can change it to, let's say, um, I want a separator. I want 2 decimal points. I can select this. You can also change it to, let's say, a an accounting format with currency sign. Let's see. Okay. or dollars here. We can also insert shapes. So in inserting, we will use this tab and then we will insert. When inserting shapes, once you click this, you will select the shapes here or which shape you want to insert. Let's say I want to do this. And then you will drag, hold and drag your key so that you can insert shape. You can change the style. You can also insert another one. Let's say this one. And change everything, the format and all here. Okay, so that's how we use our formatting under the home button and the insert illustrations buttons in Excel. How to navigate our Excel interface, we will proceed with processing our data. We can also process our data using tables in Excel. So for this exercise, we will use Spotify artist dataset. Our data includes artist name, genre, popularity score, number of followers, male and female followers, and then the total followers. Okay, so we can format this. We can select everything and then format this using the um, font section and include border. So we can select this to put borders in all sides of your cells. You can also just click this for outside borders only or thick outside borders, and you can format your borders here, the style. So for this example, I will click all borders so that every cell will have border. Okay, and just for illustration purposes, let's try changing the line color of our border. Let's see this one. Okay. Now we can um, sort our data. For example, I want to rearrange my data according to number of followers, total number of followers. Let's say from largest to smallest. There are multiple ways on how you can sort your data in Excel. First is using our sort button under the data tab. So this is our sort button, right? You can select your column, right? And then sort. And then you can choose which field you will sort your data. So let's see, total number of followers, and I want it to be sorted from largest to smallest. Okay. What happened is the entire table was sorted according to the total number of followers. So now this is arranged from largest to smallest here, and everything else followed. Let's try again using another column, let's say male follower. So we can do sort. Let's select male, and let's see, say I want to arrange this from smallest to largest. I can also do that. Okay, so this this is now arranged according to smallest to largest male followers. We can also do multiple sorting in Excel. So for example, I want to sort according to total number of followers again, from largest to smallest. And I want to sort according to, let's say, artist name. What we can do is we can add level of another, we can add another another field here, and then we can select, let's say, artist name, and I want to sort it alphabetically. So what happens is this gets sorted first, and then this is sorted after. So that multiple layer of sorting would be useful if in case you have, let's say, same information here, and you want this to be sorted, then you can do that. Okay, we can also filter our data in Excel. Let's say we want to show certain data and take out other information. We can also filter using this button. Okay, so click this. What happens is there will be a small um, drop down arrow here. That means you can click this and select your data that you want to show or hide. So if it is checked, then it is included in the data that will be shown. And if it's not, then it will be filtered out. Okay. So let's say I want to show um, certain artists only and take out the rest. So we will not check the others and select these artists only can do that. What happens is your data set will be filtered. So it will show those you have selected. That's how we filter information in Excel. You can check that select all box to select everything again. Then click OK. Okay, so that's how we filter. That's how we use the filter button. You can also filter data according to some conditions. For example, in this case, we will use the number filter. Let's say I want to filter those with followers greater than, I can select the condition here. Let's say greater than um, 15 million. Now our condition is just to show those artists with followers greater than 15 million. What will happen is those with less than 15 million will be hidden, and only those greater than 15 million will be shown here. That's how we use the number filter button. Okay, so now that we know how to use the sort and filter, we can also create an official table in Excel using the button here, insert, and um, insert table here. The advantage of creating an official table in Excel is once you update something in one column, the entire table will be updated. So you can actually update the design of your table here. You can change everything here in the format or the table styles here. So that's how we create an official table in Excel. of Microsoft Excel is doing calculations. In doing calculations in Excel, we will write formula. So in writing your formula, you can use the formula bar. This is the formula bar. You can type your formula here, or you can type it in the active cell. Okay, the convention of writing our formula is it should always start with equal sign. So this means that we are calculating something. Okay, so there are various ways on how to do calculations in Excel, but you should always start with an equal sign. All right, let's try to do some mathematical computations in Excel. We can do simple calculations like addition, for example. So let's say I want to know the total number of followers of Ed Sheeran and Ariana Grande. We will select the cell that we want to add and then use the operator addition plus sign, and then we will select the other cell that we want to add. Okay, so this is our total. That's how we use the addition formula. Now we will use subtraction. It's just the same. So, but instead of using a plus sign, what we will do is using a minus sign. That's how we do subtraction in Excel. While for multiplication, we need the asterisk. So let's say I want to multiply Ed Sheeran's followers by 5, for example. That's how we do multiplication in Excel. And last but not the least, we would like to try to do division using backslash backslash operator. So let's say I want to divide this. So that's how we use division, the backslash by 10, let's say. So that's how we do division. Again, plus sign for addition, minus sign for subtraction, asterisk for multiplication, and backslash for division. We can do multiple uh, operations in Excel too. So let's say I want to add this to this and add another one and subtract another one, right? You can do that. It's actually limitless, I would say. So just as long as you are following the right um, syntax, then you're good to go. That's how we do calculations in Excel. Now that we know that we can calculate in Excel and we realize that we can do multiple calculations. For example, I want to know the total number of followers of all our artists. So I will utilize the addition function like this, right? Can do this and then add everything up. Okay. But this is a long list. So we don't want to do it across all our data, right? That's the reason why we also use some built-in functions in Excel. Okay, so here there is a tab where we can refer to our formulas. So these are some of them. So some of the most commonly used functions in Excel are your statistical functions where you can get the sum, the average, you can count, you can get the maximum and the minimum. There are also some financial functions here. There are some logical functions as well. So you can do this to put conditions in your file. Also, you can use the text function to clean your data, some date and time functions, and some lookup functions as well. So for this lesson, we will try to explore some commonly used statistical functions. Let's try with sum first. So again, in our example earlier, what if I want to know the total number of followers of all our artists, right? So I want to know how many followers are there. So what we can do is instead of adding them up individually, we can use the sum function. So again, we will start with an equal sign. And then the way we write functions in Excel is we use the actual function. So here you can see, if you see something like this, it means it's a built-in function. If you see a symbol of fx in Excel, that means there is a function that is named like this. So sum if, sum ifs. So for this one, we will use sum. And then once you have written the function, we'll put a parenthesis, an open parenthesis there, and then you will add your cells. So you can do this, then this. It's like we are saying that, hey, Excel, add all of these cells. Okay? But this way, we are also selecting individually. We have just eliminated the addition symbol, but still we are um, uh, including everything, right? So you can do that. Or you can actually just select the entire column by using this convention. So that means, okay, so this means that sum of F8 to F72, that means you are asking Excel to get the sum of all your cells from F8, this is our first cell with data, up to F72. Okay, F72 is the last cell with data. Okay, so this is like selecting the entire column now. So uh that's how we write our sum function. That's we use colon to indicate that this is from here to here. Okay. All right. So I'll just delete this and then just use this. Okay. So that's how we write sum. We can copy this, the formula, to get the sum of this. For example, I want to get the sum of all female followers and all male followers. We can simply copy our uh, formula here and paste it here. To copy your function and formula, you can just control C, just press control C, and then go to the next cell, and then control V. So that's copying the formula. Then do it again, control C, and then control V here. Okay, that's how we write sum function. We can proceed with another most commonly used function, which is the average. So this is getting the average of your data. For example, we want to get the total number of, the average number of male followers across all artists. What we can do is, instead of sum, we will just write average. And then the open parenthesis, and then select everything, B8 to B72, right? So that's our average. Again, we can copy this and paste here, copy and paste. Okay, so that's how we use the average function. Next, we also have count function. So this is like counting the all the cells with data. That's how we use the count function. Okay, so that's count, and then select everything. The way we select our cells using shortcut keys would be control shift, pressing the control and shift button all together, and then pressing the down arrow. So again, that's control shift, and then selecting this, and then press down. Okay. So this means we have 65 rows or 65 data points here. Okay, we can copy this and paste it here. Copy and paste. Okay, we also have minimum and maximum. That means we are computing for the smallest. For minimum, that's um, the smallest value in your selection, in your selected column. And then the maximum is the largest value. Okay, so let's say I want to get the minimum. What is the minimum amount? That's min, and then selecting everything again. So that means this is 1,880,929. This is the lowest value in our data set. Okay, we can copy this, then copy. You can see it's zero. That means we have data here with zero value. You can verify this if this is something that you think is not real. For example, you can double check by filtering your data, okay, or probably sorting from lowest to highest. Okay, now we have maximum. It's just the same. So now you're getting the highest value. So this is the highest value in our cell. As we know, this is just sorted according to the total number of followers from largest to lowest. So we are expecting that this is the largest value, which holds true here, right? So this is useful if in case your data is not sorted and you wanted to see the largest value. All right. So these are some of the most commonly used statistical functions in Excel. Hi, welcome to the second lesson in our module 2. So this topic we will cover how to analyze data in Excel. We will have an introduction to our formulas and pivot table. This session will cover search functions, logic functions, text functions, and pivot tables. Let us start with logical functions. But first, we have to understand how logic is stated in Excel. So in Excel, it is stated as true or false. For example, we say 15 is less than 20. We know that that is true. So we have a formula on how to write that in Excel. As well as when we say 15 is less than 10, which we know is false. So there is also another way on how to write that in Excel, and the value would be true or false. Let's try this in Excel. All right, now that we know how to derive true or false value in Excel, we will start with our first logical function, which is the if function. This is a conditional function. So it's like saying that, for example, if we say, if it rains today, there will be heavy traffic later. Otherwise, there won't be any traffic. So that's how we think on how to, format our logical function. Okay, let's try this in Excel. For this exercise, we will use our students' dataset. Let's say you are a teacher and you are trying to update your student records. So our dataset includes first name of the student, last name, the gender, male or female, scores for each subject. So that's math, science, history, English. And then we also have the average score and some yes or no fields here for club membership. So is the student a member of clubs? Yes or no? This one is specific for math club, and this one is specific for English club. Okay, so for our if function, if the student is a club member, then we will give them special award. So we will write if the student is a club member, then with special award. Otherwise, we will write nothing or keep it blank. So the way we write this is if the student is a club member, which is this field, so this indicates yes or no club membership, right? So if this is yes, that means the student is a member of a club. So if this is equal to yes, yes, okay. And because it's a text, we will include that in a double quotation. So if this is yes, then we'll write our first condition. If the value, if this logic is true, we will write with special award. Otherwise, we will write blank. We'll write nothing in short. So this is how we write blank in Excel. That's double quotation, two double quotation, and then close it with another closing parenthesis, and that's it. So this means that if this is yes, we will write special word. If this is true, we will write special word. So we will just copy everything using Control C and then paste it here using Control V. So if you see here, this is blank because this is no. So it means our condition is not satisfied, right? So that's false. So we will write blank instead of special word. That's how we do if function in Excel. Okay, now we will proceed with our next function, which is the end function. This is not necessarily a conditional function. The output of end would be true or false. So it's like saying, it will rain later and I will work late. For the end statement to hold true, both of your scenarios should be true, or it should both happen. So it will rain later and I will work late. Let's try this in Excel. For end function, we are expecting true or false value, right? So the way we write this is like and then we write the first expression, comma, and then the second expression. In our example, we have math and science greater than 85. So for this to be true, math should be greater than 85 and science should also be greater than 85. So we will write this as math should be greater than 85. That's the first expression, comma, science should also be greater than 85. So for our first student, this is false. Why? Because math is greater than 85, but science is not. Remember, for and function to be true, both of your expressions should also be true. Okay, so we'll copy this and then paste it here. So let's see this. This is true because both math and science are greater than 85. Okay, now we have another function called the OR function. This is like AND. The output is true or false as well. But the only difference is in our OR function, it's either one, at least one of your scenarios will hold true for your OR function to be true. For example, it will rain later or I will work late. If either one of those scenarios would happen, then my OR statement will be true. Let's try this in Excel. For OR, our statement would be history or English greater than 90. So we will write this as history greater than 90, comma, English greater than 90. So this is true. History is not greater than 90, it's 87, but English is 96, which is greater than 90. This satisfies our condition. And if one of them is true, then our or statement will be true. So this is false because both of them is less than 90, so no subject satisfied our condition, so that's false. Again, if at least one of your condition is true, your or statement will be true. Okay, now that we know how to write if, and, or functions, we can actually combine all of this and create another logical function, which is the if and or if or combined. For example, if I say, if it will rain later and I will work late, then I will be stuck in traffic. Otherwise, I will not be stuck in traffic. Okay, let's try this in Excel. To write an if and statement in Excel, you have to first establish your end condition. So let's try. If math and science are both greater than 85, then we will write best in STEM. Otherwise, we will write blank. Okay? So first we have to establish our conditions, our end condition. So if math is greater than 85, math is greater than 85, and science greater than 85. So if this is true, then we will write best in STEM. So this is our first um, condition, right? Now this is where we will put our if function. So if this is true, that's the logic. We will write best in STEM. Otherwise, we will write nothing. So I'll try to copy everything. Okay, so there will only be a text that is best in STEM if our end statement is true. And for our end statement to be true, both math and science should be greater than 85. In this case, math and science are both 85. That's why we have written best in STEM. While for this one, um, science is not greater than 85. So our end statement is false. Then we will proceed with our value if false, which is blank. We can also write multiple if statements in Excel. We call this nested if. Okay, so let's try this in Excel. To write nested if statements in Excel, we have to replace our false value with another if statement. So this is how we do it. Our condition here is if the average score is greater than 98, then we will write highest honors. Else, if the average score is greater than 95, then high honors. Otherwise, if the average score is greater than 90, then we'll just write honors. Otherwise, if that's still not true, then we will write blank. Okay, so let's write it. If the average score is greater than 90, then we will write highest honors. Otherwise, instead of writing false, if this is not satisfied, instead of writing false, we'll write another if statement, which is if this is greater than 95, we will write high honors. Otherwise, if this is greater than 90, then we will write honors. Otherwise, that's the time that we write nothing, if that is still not true. And then when you write nested if statements, the number of closing parentheses should be equal to the number of open parentheses that you have written. So in this case, we have 3 open parentheses here for all our if statements. So we should put 3 close parentheses here. Okay, so here we have this as the first student as honors because the average score is 91, which satisfies our third if statement. So it is less than 95, meaning it will go to the last if statement, which is greater than 90, but less than 95, right? Okay, so while this one is 98.3, that immediately satisfies our first condition. That's why we put highest honor. This one is 91.3, so it's not greater than 98. So it will proceed with the next condition, which is it greater than 95? It's still not. And then the next condition would be, is it greater than 90? Yes, it is. So we will put honors. Okay. Same goes with those that are blank here. So all the first three, if conditions are not satisfied. So we will just write blank. That's how we do nested ifs. In our previous lesson, we have learned how to compute for some statistical metrics like average and sum, right? So we can actually introduce some logical elements to those. For example, we have average if. It's like computing for average, but we are being selective of the data that we will include in our calculation. So the way that we select which data will be included, those are the information that satisfies our if function. So let's try this in Excel. For our first example, we will try to get the average English score of female students. So we need two columns here. We need first the gender, which is this column. So if this is F, meaning the student is female, then we will get the English score. We will include this in our computation of average. Okay, average English score of female student. So we will write average if our range criteria, the condition is this, okay, this is female, and then we write this. If this is true, then comma, we will get the average of this. So 95.2 is the average English score of our female students. How about let's try to get the average English score of male students? So we will write, instead of female, we will just change our criteria to male. So instead of F here, instead of F, we will just change this to M, meaning we are getting the average English score of male students. That will be our criteria. So 87 is our average English score of male students. And we can also do multiple conditions by adding another criteria. Let's see how it works in Excel. Let's say we want to get the average English score of male students who are also a member of the English club. So what we need here would be this column. This should be male, right? And another condition, which is this. This should be yes, meaning the student is also a member of the English club. If those conditions are satisfied, then we will get the average of English score, right? So we will try average of English score if the student is male and also a member of English. So the way we write this is, now for average ifs, the range should come first. This should come first before your criteria. So this is the column that we want to get the average of, then comma, and then the first condition, this should be male, and then this should be yes. So this is how we write average ifs. If in case you have more than two conditions, for example, there's another criteria here, what you would do is you just add another one like comma and then the next condition, right? The next range and then the next criteria and so on. That's how we do average ifs. Okay, now that we know how to compute average with certain conditions, we can also do that in sum and other statistical functions. You may try it on your own. Please feel free to do sum if and sum ifs. The way that we write it is the same as average if and average ifs. You will only compute for the total instead of average. Our next lesson, we will talk about text functions. Text functions are used to clean data. We can break down long information into smaller pieces, or we can combine information together. Let's start with the most basic text functions, which are left, right, and mid. All right, for this exercise, we will use the company's dataset. The fields are company name, registration number, region, and then gross revenue. It's ranked from 2015 to 2019, and the actual gross revenue value in billion pesos from 2015 to 2019. Just for context, this is a list of the top companies in the Philippines according to gross revenue. All right, so for our first text functions, we will utilize this column, the SEC registration number. I will just hide this so that it will be easy for us. So for the left function, it says here the first two letters in the registration code is the industry code. Now we have to show the industry code. So left, right, and mid functions would let us trim our text into a certain number of characters. So you have to establish how many number of characters do you want. All right. So for the left, we will cut our data starting from the left. So the way we will write this is left, and then the text, which is this is what we want to cut, and then comma, we will write the number of characters. So it says first two letters, that's what we want, right? So we'll write through two. This is the industry code, okay? So you can actually copy that and paste everything so that you can cut all um, industry code of all company here. Same goes with the right function, except that for right, it will start from the right instead of left. So the last four digits in the registration code is the business number. Now we want to show the business number, so that's four characters from the right. Right here, and then, oops, here, and then four. That's how we use the right function. Now we have left that would start from the leftmost character, and then the right that will start from the rightmost character. We also have mid, which starts in the middle. So mid function requires you to have where is the starting point and how many number of characters do we want. Okay, so for this one, it says extract text from second to seventh place. So in this case, we want the um second character here up to the seventh place. So we will have second, third, fourth, fifth, sixth, and seventh. That's six characters, right? So mid, we want the text, and then the starting point, which is the second, right? That's where we start. And then how many characters, including the second character? That's six. So that's how we use left, right, and mid function. We also have find and concatenate under text functions. Now, find function lets us look for the placement of a certain text within a long string of text in Excel. In this example, we want to find the placement of 000 in, let's say, this text string. So it's like asking Excel, where can I find this? Right? The way we write this is find, and then you will put the text that you want to look for. So what are we looking for? This is what we want to find. And then where are we looking at? That's how we write. If you will notice, there is a square bracket here. That's actually optional, so you can um, select where to start, but by default, it will start looking from the beginning, the leftmost character in Excel. So the output of find is a number. This means 000 can be found starting from the third character in our text. That's how we use a find function. Now we also have concatenate. This function lets us combine texts together. So it's just like adding two texts together, or three or four, depending on you. So the way we write concatenate is, so text one, comma, text two, comma, and so on. In this case, we want to concatenate industry code and business number. Industry code has been extracted earlier through the left function, while business number has been extracted through the right function. Now we want to combine them together. So concatenate industry code, comma, and then business number. If in case you have more text that you want to include, just put comma and then the next text. So now it is combined. That's how we use concatenate function. And we will talk about search functions. So search functions are used to search for a value of a certain data, which may come from a different workbook or a different worksheet, as long as you have a common column to refer to. The most commonly used lookup functions are VLOOKUP and HLOOKUP. VLOOKUP means vertical lookup, so you're looking vertically first. Let's see how it works in Excel. In this example, we will try to look for the industry name of each company and the short name, the industry short name of each company. We only have the industry code, which is this, right? And we don't have the name and the short name of the company, which can be found in another sheet. This is our reference sheet. So this is the critical table that we will use in our VLOOKUP function. Okay, so in order for us to look for the industry name, we will use VLOOKUP and then look for this. Where should we look? We will look here. You can select the entire column or just select the table itself. Okay, and then how many columns do we need from the leftmost column? Okay, in VLOOKUP, you would always start with the leftmost column of your selected reference table, right? So this is the first column, this is the second column. I need the second column, so I will put 2 here. And then the match type, right? Again, if you want approximate match, like something close to what we're looking for, then we will use true. But if we want the exact match, we will use false. So PF, we found out that this is financial institution based on our VLOOKUP, right? Let's try this in PT. PT is telecommunication, just to check. We look back here. PT is telecommunication. Yes, that's true. Okay, that's how we do VLOOKUP. We will try this in this short name. So short name now in our reference table, short name, industry short name is on the third column. So instead of putting 2 in our column index here, we will change this to 3 because our um, short name, the column that we need is on the third column from the leftmost value. Okay, so that's how we do this. Um, On another note, you can also use 0 and 1 for your match type instead of writing true or false. Okay, so you will write 1 for true for approximate match or 0 for false or exact match. Just to show why, because in Excel, the numerical value of true or false is 1 and 0. Let me just quickly show you. So that's 1 for true and 0 for false. So you can also substitute 0 here so that you will not type, it will give you the same answer. Okay, that's it. Now we will take a look at each lookup. This works as you are looking horizontally first and then looking at the rows from top to bottom. Let's see how it works. So this is our reference table for each lookup. Let's say we want to show the total revenue for BDO Unibank using each lookup function. So it's like asking Excel to look for the seventh row from the topmost row in our table, but using BDO as your value, as your lookup value. So we write it this way, each lookup, and then we write BDO Unibank. Okay, this is what we're looking for. And then our reference table is this, right? And then we write 7 for our row index number. 7 because the total revenue is on the seventh row if you count from the topmost row. Okay. And then again, the match type, it's either true or false. We want the exact match, which is false. So this is our total revenue for BDO Unibank. We can also try 2017 revenue of Nestle Philippines using HLOOKUP as well. So 2017 is on the fourth row from your topmost row, and we want this Nestle Philippines Incorporated, right? So we will try to do it again. HLOOKUP Nestle Philippines. And then the same table, but instead of writing 7, since we want 2017, that's on the fourth row. So we write 4 and then the match type. So we have found this. This is our value for the 2017 revenue of Nestle Philippines using H. Okay, so for this exercise, we will be using the pivot dataset. This is pre-prepared, but it includes the same data as what we have used in our text function exercise. So we still have the company names here, the registration code, industry code, business code, registration year, region, short name, industry, and 2018 and 2019 revenue. All right, so before you start creating your pivot table, always make sure that um, all your columns here have headers or have names here. So to start off, you will click Insert and then Pivot Table. This box will appear. First, you have to select the range or the source of your pivot table. In this case, this is our data source, right? So to know which cells are included in your data source, that would be all the cells inside the dashed green box. In this case, that starts from A7 to J21. Okay, let's just try to see. That's until J21 from A7. Okay, and then we have to choose where you want the pivot table to be placed. It's either you can create a new worksheet or you can also create an existing worksheet. If you choose existing worksheet, you have to select where to place from these existing worksheets. So in this case, let's say I want to put the table here. Let's say I want it here in M6. So it will be written here that I want it here in M6. But for the purpose of this exercise, I will create a new sheet. So I'll create new worksheet and then I'll click OK. What happens is Excel would create a new worksheet for me where there is a pivot table here and the fields of the table is here. these are the columns that we have in our original data source, right? So this is the reason why we need to have all columns to be named because it will be placed here. And these are the fields that you will drag and drop in your boxes here to play around your pivot table. Okay. Just to summarize, we have learned important data processing tools in this lesson. We have learned how to use logical functions, text functions, search functions, and we have learned how to manipulate data using pivot tables. Thank you and see you next lesson. In this lesson, we will talk about data visualization. Data visualization is a graphical representation of data using visuals. An effective data visualization would reveal insights, patterns, or trends which may not be easily seen on the data and usually would lead to informed decision making. For us to fully utilize our pivot table, we will learn some other useful techniques that are commonly used for this. So, for example, you have an updated information in your raw data. Let's say in this example, we want new information. We just received an updated version of this row, let's say, or this row. So you can update it here, and then you can click the refresh button here so that all information in your pivot table will be updated as well. So it's either you click refresh, meaning we are specific to this table, or refresh all, that means all other tables or all other pivot tables in our workbook will be updated. Let's see how it goes. So we are here in energy, Manila Electric Company. Let's say this is our value for 2018. That's this, let's say I will update this to, suddenly we knew that there has been an additional 500 for this, and this one we say values changed to 798 and 1109. Now this is what we are expecting to change. If we click refresh, what happens is this gets updated, right? And the total gets updated too. So that's how we use the refresh button. Next technique, it's peeking behind the scenes. So, for example, we don't have this information. Let's say we only have this, and we want to know what's the information under energy, let's say for 2018, because usually pivot tables are used to see the summary, right? But there are cases when you will have to check each detail, right? So what you will do is to double click on the data. So in this case, I will double click here. What happens is there will be a new sheet that will show me the details of what I just clicked, energy 2019. So I will have this information. It's like your raw data, but filtered this way. If I have other filters here, then that will also be applied to the data here. This is in table format, so you can easily manipulate this as well. Another tool that you can use is filtering rows. So for example, we have here this list, but we don't want to show um, telco and utilities since they don't have data in 2018, let's say. So, but I still want to put my industry on the list. We can simply put industry here in the filter, but if we do that, then it will not be shown as list. So you have an option to actually filter in the row itself using this button here. So that's a drop-down filter for rows. Then you can select from here. Again, I want to remove telco and utility, so let's untick it here. That's what happens when we filter from here. Another important tool that we can use to fully utilize our pivot table or to, manipulate things easier here is this button here, the settings of our pivot table. So if you click here, you can choose your layout of the pivot table fields because by default it's like this. The fields are here on top and then the boxes are layout like this. So when you click here, you can choose this where the fields and sections are here on the side and the list of filters, rows, and columns are here. This is useful when you have long list of fields so that you can see it easily. You can also adjust the width of your pivot table pane in case it's too small for you. So again, you can change and show the fields only or show the um, boxes only here. All right, another thing is by default, our list of fields is sorted according to how it is arranged in our raw data, right? Your company goes first and then registration code up to the revenue over here. But you can sort your data alphabetically here. This is really useful when you have so many information here in the long list and you're struggling to find where your data, your column is. So you can sort it here, right? Or you can put it back in your original data source order, or you can actually search here. Okay, so this is very useful. That's about it. I hope you have learned in this lesson. In summary, we use column charts and bar charts to compare values of different categories. We use column charts ideally for fewer categories, while we use bar charts if the category names are long texts. Some of the best practices that we have learned. First, we need to always add labels for easier reference and avoid using too many colors, or at least try to put color emphasis on your insights. In creating charts in Excel, we will utilize the Insert tab here and the list of charts here. There are templates where you can select depending on your data, and there are also recommended charts prepared for you. The first thing that we will take a look at is the column chart. It is used to compare different values of different categories. This is the data set that we will use, the industry list with 2019 revenue. To create column chart, you have to select the entire data set first, and then select the template here, which is column chart here. And it's as simple as that. We have just created the column chart for the 2019 revenue of each industry. Now, let's take a look at the parts of the chart. So this is the chart title, and these are your axes. This is the y-axis, where we can see the actual values, and these are your categories. You can change the chart elements here. There is a button here where you can select which elements you want to show or hide in your chart. For example, we have here the axis button. If I uncheck this, the axis will be gone. You can also select primary horizontal axis and primary vertical axis over here. You can also try to put titles on our axis. So we can select this and unselect it as well. Once you have shown the axis title, you can edit it by clicking your text box over here and update the title. We can also select or unselect the entire chart title. So you can also update your chart title here by clicking the text box and format your title or change the text. There is also an element for data labels. This is extremely important because this gives us the actual value on the onset of our chart. So you can select this and then it will show the actual value over here. You can update the placement or the font or the format generally of your data labels by clicking the arrow here and try to format the placement here, or you can select the entire formatting over here. There's also an option to add data table, which gives you the label at the bottom of each chart in a table format over here. If you have added the data labels here, it is okay not to put the data table here because it will be just redundant information. We can also try to remove the grid lines. Grid lines are what you see at the back of the visual itself. By default, grid lines are gray, and we can format which axis we would like to put grids on. Legends are also important elements of our chart because it helps us identify which category is this color or this bar is for. So in this case, we only have one category, which is 2019 revenue, and we know that it's blue, and that's why our legend here is only one. So you can also format your legends here by clicking this format button here, and then more options, and do the formatting here. That's how we do column chart. Now we try to do another form of chart, which is the bar chart. In terms of function, there's not much difference between column chart and bar chart. Bar chart is just more preferred when our category names are longer in text form. The way we create bar chart is the same. We have to select the entire dataset, click insert, and then select bar chart here. Bar chart is the horizontal version of your column chart. So we also have the same elements, the axis, category labels, chart title, grid, and the way that we update each element would be the same. So we will also use this button, the chart element button, to update things here. We can also format the entire chart using this chart style because there are other chart templates over here where we can select the formatting. We can also change the color palette of our categories over here. We can also update our charts using the buttons here. So we also have the chart element button here. We can change the layouts here, change colors, and change the style over here. While we have the liberty to change the colors of our charts using the formatting buttons, always try to not use so many colors in your chart, and as much as possible, if in case you have various categories, try to use the same colors for each categories for easier comparison. Now we'll try to learn how to make line charts. Another way to compare our data is by the use of line chart. Line charts are used when we have time component in our data set. In this example, we'll try to use the company data set over here with its revenue from 2015 to 2019. You have to first select your data, just like what we did in bar chart and column chart, for us to be able to create a line chart. And then we will utilize the insert tab here and select this option here, which is for line chart. Now we'll try to inspect the data source of our chart by right-clicking on the chart and clicking Select Data over here. This window will show us the data source of the chart. So here we see the data range, which is the selected table over here. Now, there are many ways to add additional series in your chart. One way is to update the data range here. So you can actually just select another set of cells over here so that your chart will be updated as well. As you can see, we have added another line here, and we can also see it here in the list of series over here. You can also use these buttons to add, edit, or remove some series which you may need in the chart. And there's also an option for us to switch rows and columns by clicking this button. So what happens here is this list will be on your horizontal category, while this one will be placed here. Now, the way to update your horizontal labels, you can select this and select the list of cells that you want to be your label. That's how we create line charts. We also have the same exact chart elements here to update the information on your chart. So you can also select this to add title, or select this to include legends, or add or remove grid lines using this button here. In summary, we have learned that we will use line chart to show trends or changes over time. And for some of the best practices, always try to remove distracting elements and avoid using more than 7 lines, because usually our chart becomes cluttered. Another useful chart is called combination chart. Let's try this in Excel. Now, if we want to display different types of data all at the same time in one chart, we can use combination chart. This allows us to show information with varying scale. For example, in this case, we have company revenue over here in information over 200, while we also have customer satisfaction percentage, which is shown in percentage in less than 100%. The way we will do it is to select the entire data again and use Insert and click Recommended Charts over here and try to go on the list of all charts and select Combo here. Now here you can choose which chart type you will want to use for each category. In this case, by default, it's column chart for the revenue and line chart for the customer satisfaction. You can select here and change everything. You can also change things like that, or use the default template over here. The important thing in using combination chart is to be mindful of your axis. So if you select secondary axis here, you'll have another axis at the right part of your chart over here. We will know that this is for our second series, which is customer satisfaction, because the range is different. It's from 0 to 80%, which we know is the range of our customer satisfaction percentage. You can change the range of your axis by right-clicking on the axis itself and click Format Axis. Now this pane will show and change the boundaries of your axis using this button. So we can change the minimum, which is now by default it's 0, and the maximum is 0.8, which is 80%. So we can also change this to 1 so that it will be 100%. So now our maximum axis for our second axis is 100%. We can also change this using the same process. So we can change from 0 to, let's say, 500. Now the axis has changed, and we've noticed that the length of our columns have changed as well accordingly. For us to be able to identify which axis is for which chart, usually we change the color of the axis to the same color as the chart itself. So you can right click and then change the colors here. Now it would be easier to identify that this axis is for the blue chart here, the column chart, while the orange axis is for the line orange chart here. Same button for updating the elements using this one. You can also change the chart title here. That's how we create combination chart. In summary, we use combination chart to display different types of data with varying scale. Remember to always be careful when setting the axis scale of your chart because axis scaling may change the interpretation of the entire visualization. And if you will show the axis, always try to make the chart color and the axis color the same. Now we will try to learn pie charts and donut charts. Pie charts and donut charts are used to show proportions as part of a whole. Numbers are in percentages and all data points should sum up to 100%. Remember, do not use pie chart or donut chart if you have more than 6 slices or if your slices have roughly the same size because the difference in proportion will be hardly visible. And always try to keep your charts clean. Another way to compare proportions or visualize parts of the whole is through pie charts and donut chart. This is how we create pie chart and donut chart in Excel. So you will highlight your data and then go to Insert tab and select pie chart and donut charts here. So the first row is for your pie charts and this one is for the donut chart. Let's try creating pie chart first. And then we'll try to do donut chart. You can adjust the size of the pie or the donut or the hole inside by formatting your data here. And then this is a donut hole size button here. You can just adjust. And then you can also add labels for each slice using the data labels option here. And you can format your labels. You can format your text here, the alignment of your text and the font, the colors, and the borders of your labels over here. Let's try it here. So you can, in formatting your labels, you can select the actual value. In this case, this is the actual value, so that's 60, 30, 10. And you can also select other values from different cells. You just have to put it accordingly in your table over here and select here. And you can also update the label positions here and the number formats over here. All right, so that's how we do pie chart and donut chart in Excel. Now we will learn stacked bar and stacked column chart. When we want to compare proportions of many categories, or we want to compare proportions over time, we can use stacked bar chart or stacked column chart. In this example, we have the company dataset and 2018 and 2019 revenue. Should have to select the entire dataset and use the Insert tab and select Stack Column option here. As we can see, we have the combined 2018 and 2000 revenue here for each company. We can change the axis using this button and change the label here. We can change the axis by clicking the Select Data button and change the range here. This way, we are showing the total revenue for both 2018 and 2019 as well. But if we want to show the breakdown of 2018 and 2019 revenue per company, what we can do is switch the rows and columns by using this button. So in this case, we are seeing 2018 and 2019 revenue, which is broken down per company. That's how we do stacked bar chart. Now there's also another form of this, which is the 100% stacked bar or 100% column chart, where we would like to compare the absolute percentage that each value contributes to the total. Let's say we wanted to know the breakdown of 2018 revenue in percentages. So this category should always sum up to 100%. Now, if you want to add another element to this, which is 2019 revenue, the total percentage of the way we do it is to select 100% stacked bar chart over here. And here we can see the breakdown of each company for 2018 and 2019 revenue. Although we can change this by switching our rows and columns as well, so that we can see the change of percentage over time for each company. So again, the length of the bar or the height of your column in a 100% stack bar or stack column chart should always be the same across all categories, because again, the total should be 100%. The axis, the maximum axis should be 100% as well. Let's try to add some labels over here so that we will know the percentage per company. That's how we do 100% stacked column chart or 100% stacked bar chart. Creating 100% stacked bar chart and 100% column chart and the normal stacked bar and stacked column chart is the same, but the only difference is when you're creating a stacked bar chart, you will show the actual value, while a 100% stacked bar chart or 100% column chart, you will show the proportion of each data point to the total of each category. In summary, we use stacked bar or stacked column chart to show composition of different categories or proportion over time. In 100% stacked chart, y-axis never vary and is always up to 100%. The sum of each category breakdown should be 100% as well. Some of the best practices that we've learned. First, avoid comparing more than 5 categories because comparison will be hardly visible. And always try to use the same color breakdown for each category. So in this lesson, we have learned some of the data visualization concepts. When we are trying to compare categories, we use bar chart, column chart or line chart. Line chart is used when we have time components in our data. While when we want to show proportion, we will use pie chart, donut chart, or stack bar or stack column chart. I hope you've learned something. See you next lesson. In this video, we will talk about visualizing our pivot table. So we will create charts from pivot table. Let's start with creating our pivot table. The data set that we will use here is the same data set, company data set from 2015 to 2019. So let's first create pivot table. So remember the name of our pivot table is pivot table 4 here. Let's say I want to show the revenue by industry for 2050, let's say. Okay, so this is our 2015 revenue. Now, to create a chart from this pivot table, all you have to do is to go to the pivot table analyze tab over here and select pivot table chart. This window will pop up and you will choose which visualization you want for your table. So you can see here there are buttons over here, right? So these are also the same buttons in your table itself. You can filter here, but honestly, this is considered clutter in our chart. So we can remove this, right? Just right click there and then click hide all field buttons on chart. All right. Let's sort this. And remove this. Okay, so this is our table and chart. It's the same process as to how we create normal charts, not from pivot table, but from normal data sources. It's actually the same, but we will just select from the pivot table analyze tab here and specifically select pivot table chart. Okay, let's try to create another one. And let me show you that we can update multiple charts all at once. So let me try to create another um, table. We can also create multiple charts from the same source or different sources and update it all at once if we have charts from pivot table. So let's try to create another table here and try to create another one. So this is pivot table 4 and this is pivot table 5, the newly created one. And let's try probably company. Okay. Now we will create another pivot table chart from this. All right. Let's remove. Okay. Uh, so this is our chart from this pivot table number 5. Okay. So we can update all these together all at once by using slicers. But before that, Let us change the name of our pivot table first so that it will be easily identifiable. So to change the name, you have pivot table options here, and then this is the pivot table name. Let's say industry. All right, and this one, right click, pivot table options, company. Okay, we have renamed this table to industry and this one to company. Okay, we can insert slicers in our pivot table, right? So that's under pivot table analyze and then insert slicer. As you can see, slicer is under the filter group here because slicer works as filter, but it can be placed outside of your table. So it is movable. You can place it anywhere in your chart. Let's say we want region as the slicer. What happens is there will be this box. This is called the slicer. Okay. And this is connected to this because again, we click here and then insert slicer. So what happens here is if we filter this, let's say I select national capital region here, our data will be filtered to those under National Capital Region only. You can do Cordillera or Calabarzon or select everything by clicking this so that you will activate multiple selection and then click. Or if you don't want that, you can just press Shift and then uncheck. Okay, that's how we use the slicer. But the most important function of this is you can connect this to multiple tables. So all you have to do is do right click and then choose slicer settings here. All you have to do is right click and choose report connections here. So as you can see, we have the industry table here, which has checked because this is where our slicer is connected. We also have pivot table 2 here. This is another pivot table inside our workbook. So we will not use that, but instead we want to connect to this company pivot table, which is this one that we have just renamed. When I check here, now what will happen is this slicer is connected to this one and this one. I click OK, and we filter. Look at what will happen to this chart. It gets updated as well as we filter our slicer, right? So that's how we use slicers. The mechanism behind this is actually connected to your pivot table, not directly to the chart. So here, the filters on your table gets updated, and in return, your charts will be updated as well. So let me just fix this in case I want to create, let's say I want to make this a report style of sheet now. We can do this, right? And then we can update the entire chart so that it will be a little bit more um, easier to refer to. Okay, so that's how we create charts from pivot table, and that's how we also use slicer. Hi, welcome to lesson 4. For today's lesson, we will talk about date and time functions, how to resolve formula errors, some other useful buttons, and other important techniques in manipulating pivot tables. For this part, we will learn about date and time functions. Date and time functions allow us to perform operations on Excel date and times. For instance, we can calculate the number of days or months or years between two dates. For this exercise, we will use our call center dataset with the following fields. Our first functions would be now and today. This allows us to show the date today. Now, this is how we write this and today. Only difference is that today shows us the date only, while now would show you the date and time. It actually depends on the formatting of your cells as well. Our next functions are date, month, and year. The output of date, month, and year are numeric values. So day would give us 1 to 31, which is our days of the month. Month would give us 1 to 12, which is our months of the year. And the year is the actual year itself. The argument for completing this function requires us to have serial number. Serial numbers are numbers that represent the date. In Excel, dates are stored chronologically, where January 1, 1900 is 1, January 2, 1900 is 2, and so on. So the output of this are numeric values. The way we write our date functions would be day for day, and you can link it to your actual day. While for month, we will use this function. And year, this shows us that for this data, we have 1 for day, which is the first day of the month, and 1 for month also, which is the first month of the year, and 2015 for the year. Let's try to check the last data we have here, which is March 31, 2015, and we have extracted 31 for the day, 3 for month, and 2015 for the year. We also have another function called date. This is the reverse function of your day, month, and year, because here we are combining these three to form the date. So, for example, you have your year, and then the month and the day to form your day. This is useful when you have different columns for your day, month, and year. For example, you don't have the original date, then you can use the date function. Another way to use your date function is to actually write your numbers within the function. For example, we have here 2022, and my month is August, and my day is 12. This gives me August 12, 2022 as day. Our next function would be workday and date diff. Workday is like asking Excel what date will be, let's say, 15 days from now. The way we'll write this is workday, and then you will input the start date, let's say this one, and then let's say 15 days from now. As you can see, there's an argument here for holidays, meaning we can exclude holidays in our counting. Remember, this would only give us working days, meaning only weekdays. So in this example, January 22 is 15 working days from January 1. While date diff is computing for the number of days or months or years between two dates. So here, the argument would be the start date, the end date, and then the unit, which allows you to indicate if you want to compute for days or months or years. So the convention would be D for days, M for months, and Y for years. So here we see there are 21 dates between January 1 and January 22, 2015. That's how we use workday and date diff. Now let's proceed with our time functions. Actually, this is like our day functions, but instead of writing day, month, and year, we will write second, minute, and hour. So let's try it here. For second, we will use this. The serial number is the same here. And here we can see that the output is 58 because in our data, it's 9, 12, 58. So seconds is 58. Let's try minute. This is 12. And for hour, it's 9. That's how we use second, minute, and hour functions. We also have time functions that is the same as date functions, but it's like combining these elements together so you can form time. What we need for time is your hour, which is this, and then minute, this one, and then second, this one. So it will give you the exact time. Just in this format, we don't show the second, so you can't see it here. And just like the date function, you can also just add the exact value. Let's say time. Let's say we have 7 in the morning, say 7:30, and the second will be 5. It will give you this value. That's how we use second, minute, hour, and time function. There will be times when you will encounter errors in writing your formula. In this part, we will try to understand what the errors mean and how to resolve them. First, we have the multiple number signs or multiple hashtags. This means that your column width is not enough. All you have to do is to adjust the width to fit your text inside. For example, if this long text wouldn't fit in your cell, you will see multiple hashtags over here, and all you have to do is to adjust the width of your column. We also have hashtag ref exclamation point error. This means that our reference cells do not exist. All our functions here are linked to this column. So in case we will lose our reference cell, all of these functions will give us ref exclamation point error. For example, this is deleted, then this will happen. The way to resolve this is to either bring back the reference column or link this to a new column or new cell so that the function will still work. Next, we have hashtag name question mark. Excel is unable to recognize your function. Most probably, there is a spelling error in your function. Let's say this would have a different spelling, then it will give you the name error. Next, we have hashtag NA. This means that Excel can't perform the formula or can't find what it has been asked to look for. This usually happens with lookup functions. For example, when the lookup value does not exist in the source data. In this example, let us inspect the call ID first. So our call ID would start at 0001 and it's in orderly manner. So let's say we will have, let's hide this first. Let's say I want to search for ID 1, which we know that is not on the list, and search here. Excel will give me an NA error because what we are looking for, which is the ID 1, is not in our list. Hashtag num exclamation point error means that there is a problem with a number used in the formula. So let's say you will remove all this, because these are numbers, what will happen is all your functions that are dependent to your numbers would give us a num error. Hashtag div0 error means that we are dividing something by 0. Mathematically, we can perform this calculation. Two things we can do here. Either we can update the cell with 0 value, or if the cell is blank or it has no data, you can add value as necessary. In this example, we will bring back our other fields. So we will use the speed of answer column, and this is in seconds, so we will try to convert them to minutes by dividing by 60. We will just hide this first. Alright, so we will try to divide this by 16 so that we will get the minutes conversion. Now, if this is blank, we will get a div0. Or if this is 0, we will get a div0 error. So the way to resolve this is either you update this, you add data here, or you update this cell. Hashtag value means that this is a general error. This can mean that there's something wrong in the values you are using or in the formulas that you have written. It can also be a combination of all other errors. We also have some additional functions for fixing our errors. We have is error and if error. Let's try this using the previous functions that we have done. So let's say, let's focus on the date. Let's say we don't have this. So now we have num errors here. Is error is like asking Excel if this is erroneous or not. So the value would be true or false. Okay. That's false, meaning this is not an error value, right? While this is true because this are erroneous values. Okay. While if error is like adding condition, telling Excel that if this is erroneous, then I will do this. Usually, people would change erroneous values to blank cells. So it's like if error, if this is error, then I will change it to blank. Otherwise, Excel will keep the original data. As you can see here, this has turned blank because these are erroneous value and this condition holds true. You can also add if error in your original formula so that you don't have to create another column for that. You can actually include the if error function inside the original formula so that you don't have to create a new column for that. Let's say we will put it here in our original date function. So it's like saying if this is an error value, then we'll put blank instead. So now this has turned to blank, and our is error function here has become false because this is not erroneous anymore. It's blank now because of the if error function that we have placed in the beginning. For auditing our formula, we will utilize our formulas tab here and the set of buttons over here. So first we have trace precedence and trace dependence. Let's say we are here in our cell M2. Now, if we click trace precedence, it would show arrows from K2 to N2, L2 to N2, and M2 to N2. Those are the cells contained in your formula. So it's like asking Excel, what are the cells that I am dependent at? While on the other hand, if we click trace dependence, it will show arrow from N2 going to the cells that this is contained in. So it's like asking Excel, where am I needed to? If we click remove arrows, every arrow that you have just shown will be removed. Okay, so it's an easy tracing of the cells contained in your formula and where your cells are needed at. Next, we have the error checking button over here. So if we click this, it will show us a window to check our error. The cell formula is here, and the description of the error is here. So in this case, this is our formula, date M7L7K7, and then the number error. There is a problem with the number used in the formula. So this is basically just a description of our error. Here, there are other buttons. Help on this error will take you to the web where you can see guides on how to fix your error. Show calculation step is the same as this one, the evaluate formula button over here. Ignore error will just let you ignore this as an error, and then edit in formula bar will let you edit the formula itself. So let's try evaluate formula. Evaluate formula is actually just letting us see how each argument inside our formula is derived one by one. So in this case, M7, if we click evaluate, the value of M7 is 0. Next is L7, which is again 0. And then K7 is again 0. And in return, it gives us a number error. So this will allow you to see which part of your formula you started to have error. So let's try another one, which is a not so erroneous information and try to evaluate. We also have this button here, the step in button. This will add another layer of evaluation where we can see where each argument is derived from. So in this case, M2, this is our year, and it is derived from B2, which is a formula. And if you click step in, this is the actual day of B2. So it's from the raw data. So this is the formula used for B2, and then in turn it was used for the date function. That's how we use the evaluate formula and step in button. So if you click step out, it will just take you back to the original level. Okay, so that's how we use the error checking and evaluate formula buttons. We also have useful buttons for auditing your formula. We have trace, precedence, and dependence button. We have error checking button and evaluate formula button. Conditional formatting is another useful button that allows us to automatically format our cells depending on certain conditions. For example, we can use conditional formatting in this field, satisfaction rating. If we will inspect, we have values from 1 to 5 for satisfaction rating, and if we want to automatically format this using conditional formatting, we will use the Home tab and conditional formatting button over here. So there are various options here. You can see there is an option to highlight the cells depending on these criteria. You can also highlight top 10 or top bottom items. You can also create gradient fill. You can also create formats depending on different color scales and also add icons to your cells. So let's try this first. Let's say highlight cell rules. So let's highlight values of cells greater than 4. So that means all those 5s and 4s will be highlighted, right? In order for you to remove the formatting, you can click this again and select this clear rules from either selected cells or from the entire sheet. Let's try another formatting, adding icons to our cells and setting some rules. So in order for us to edit the rules, we click Manage Rules and Edit Rule over here. So select this and Edit Rule. I will change the type to numbers, and let's say I want the icon to be green when the value is greater than or equal to 4, and amber when it is greater than 0 and greater than or equal to 3, and red when less than 0. Click apply and OK. So this is another conditional format that we do. So amber for 3, and all those less than 3 will be red, and 4 and 5 will be green. Okay, so that's how we use conditional formatting button. Another important tool is our text to column button. So this is under Data tab and Data Tools. This is the button for text to column. This is used to break down certain column into different parts. For example, this is our data set, our call center data set. And we want to break it down per agent ID, date, product ID, calls, and so on. So if you click text to column, you have to choose the file type that best describes your data. So you can choose delimited because here we will be given the option to choose what is our separator. In this case, in our example, we have semicolon as our separator. You can also choose comma if that is applicable to your data set. You can choose space or others and type it here. Okay, in this case, we will choose semicolon. And if you can see here, this is the data preview. This is what will happen to your data after you use this text to column button. So here we can see that it has been broken down according to what we want using the semicolon as separator. So if we click next and finish, new columns will be created, and the original long text over here has been broken down into multiple columns. That's how we use text to column button using limiters. That's how we use text to column buttons using the limited option. We also have fixed width option. So let me just put everything back again to its original form. And let's try using fixed width option. So in this case, Excel will allow you to draw where you want to cut your data. In this case, you will click, for example, I want to cut here and make this as my first column. And then here, this will be my second column, and here, my third column. If you want to remove the lines that you draw, just double click on the line, okay, and create new lines, for example. If I click next, this will happen, and then finish, and then my data will be broken down into the lines that I created. That's how we use text to column button using fixed width option. Another important button here, we have the remove duplicates button. From the name itself, it allows us to remove duplicate values in our columns. In this example, we will use the department column here. Let me just copy and paste here. So if we click remove duplicates, it will give us this window that allows us to select what do we want to do. Do we want to expand the selection, meaning when we remove the duplicate values, the entire row will be removed. Or we can just continue with the current selection, meaning we will just remove the row for the current column that we have selected. In this case, we just want to remove duplicates from column X here. So we will click remove duplicates and then click OK. This window will appear. It shows us the number of duplicate values found and removed. Here we have 4,995 duplicate values, and we're only left with 5 unique values. Click OK, and that's how we use the remove duplicate button. Next, we have the data validation button, where we can add criteria to our workbook in case you need some validation before data gets inputted to your workbook, then this is the button that you will use. Data validation is under data tools, so we can click this. And for example, I want to add a validation that my data should be between 1 and 10 only. So the minimum would be 1 and the maximum would be 10. So we are creating data validation for cell Y2. And if I type 1, it will push through. If I type 2, it will push through. If I type 9, it's still okay. If I type 12, then an error window will pop up that shows that this value does not match with the validation or with the restrictions of the cell. You can either retry, cancel, or close this. Okay, so that's another way to create restrictions in your data. Another thing you can do with data validation is to create a list. So we can create a list or drop down option for this. So this is our tick box for another data validation we can do is creating a list. So here we can create a list with drop down option within the cell. So here you can type what are the options. Let's see. Let's try yes, no, and maybe. Once you click OK, there will be a small drop down arrow over here, and when you select this, your options will appear. So let's say yes, or maybe. You can also copy this and paste here to copy the entire drop down list. So that's how we do data validation in Excel. You can explore other options here. You can customize things, and you can also add validation to your text length and also some validation and dates. Okay, now that we have covered some important tools and some other important functions, we will try to learn more about pivot tables again. We are still using this data set, our call center data set, and we will just create a pivot table out of these uh, columns until customer satisfaction over here. Insert pivot table. Okay, so this is pivot table 6. And let's say I want to see the date. And I just want to know how many calls I have from January to March. So that's 5,000 calls, right? So this is a normal pivot table sourced from this table, right? Now, what if we have additional rows here? So let's say, let me just add another row here, and let's add a day, and let's just do a dummy data here. Let's copy. Okay, so we added ID 5001 in our data source, right? And if we refresh this, okay, if we try to refresh this, nothing happens. Why? Because the data source of your table is fixed from A1 to G5001. Okay, G5001 is actually this, G5001 is this. So our data source is up to row 5001 only. When we have added another one, our data source should be up to 5002. But since our source is fixed, the table did not update. Okay, the solution to this is to actually create um, a table first for your data source. Let's try. Let me just paste this, excluding the 5001 newly created ID. Let's see. Okay, so this is our um, original data, right? Up to ID 5000 only. And let's try to create a table for this one. Insert table. And now this is an actual table, right? If we create a pivot table out of this, um, the name of the table is table 2. Okay, let me just rename it. Um, Test table. The name of the table is table 2. Let me just rename this to test table. And then we will create a pivot table out of this. Okay. And I will choose the existing worksheet because we have already created the sheet for pivot table. So let's place it here beside our first list, which is pivot table 7. And let's recreate this. And this. Okay. So this one is sourced from original table, while this one is sourced from test table, which is an official table in Excel. Okay. So if we update our test table and we add another row here, let's say 5001 for April, and then so we have just added a new row, right, for April. And then what will happen here is if we refresh this table, your pivot table will be updated. You see, this is the newly created entry from this one. Unlike here, when we add 5000 ID 5001 at the bottom, right? This one, it did not update. So in industry practice, it is also advised to first organize your data sources for the pivot table, like create official tables so that it's easy to update once you do some additional inputs, because there will be times when um, some other people will use this probably, and then their table will not reflect the actual updated values. So it is always important to check your data sources as well first. Next, we will explore pivot table options. So let's say, let me just copy this and change our fields. let's say we want to see this. Okay, but we noticed that we have some blank data here, and we are in the pivot table now. So what you can do is either update your data source, right? Or you can actually explore the pivot table options. All you have to do is right click on the table and click pivot table options here, and this window will pop up. So we have here the layout and format of the table, the filters, display, printing, data. For this one, we will utilize Layout and Format tab. So here, under the Format, we can see here that for empty cells, show blank. So that means we will show this, just an empty space for empty cells. So this is activated because it has check over here. So let's say for empty cells, let's show no data instead of blank. So look what will happen to ID 0006, which is blank here. And click OK. So what happens is blank cells uh, have been changed to no data. Okay, so that's how we use this button. You can also use the this one for error values, show something. So we have learned how to fix some erroneous data, right? But if you're in a pivot table, you can do this as well. You can select this and then tell Excel what you want to show. If there are error values in your pivot table, let's say you have this error, div zero error, or something else, you can clean that here. Okay. You can also update your pivot table upon opening the file without clicking the refresh button. So all you have to do is to select pivot table options again here and then go to the data tab and enable this refresh data when opening the file. So when you click this, and then from the name itself, your data in this pivot table, specifically in this pivot table, will be refreshed once you open the file. This is extremely useful when, for example, you have data sources from other files or other external databases, let's say, and then this file is sent to somebody else, and they don't necessarily have access to the data sources, and then the pivot table that they will see or the charts that they will see will reflect the updated data once they open the file. So that's about it. I hope you have learned some tips and other techniques to further utilize pivot table. Hi! In this lesson, we will talk about data storytelling. How to tell an effective data story, creating compelling narrative. We'll talk about the Gestalt principles of visual perception and some of the best practices in generating insights. We will also have real-life tasks considering the storytelling principles as well as the task context to make the story compelling and precise. What is a data story? Why are we doing this and why is this important? Well, data story is a form of communication. You are communicating your insights, the results of your data analysis to a specific audience. And so, it should tell us what the big idea is. Your audience should take away a thing or two out of it. The key elements are data, visuals, and narrative. Data includes the series itself, its statistics, let's say the averages, totals, or other metrics, which are usually presented in summarized form. Next is the visuals. In the past lessons, we have learned how to create and choose the right visuals. And another equally important element is the narrative. Your data and your visuals will be wasted if not presented in an effective narrative. So in this lesson, we will try to discuss how to create a compelling narrative for your data story. But before that, let us take a look at some of the examples of visuals that we have seen online. The first one is this one, the chart on residential real estate index, with many overlapping lines And at first glance, it is not easy to comprehend what the chart is trying to show. But if you will look closer, you will see that all the lines relatively increased over time. The title has another data point, which is Q1 2014 equals 100. But we are not sure how relevant this is in the visual. Choice of colors too can be improved, and we will learn in this lesson how to do that. The next one is employment rate by region. This is a neat visual, actually, with good choice of color. Aside from the side-by-side comparison, we can extract some other useful information here easily, only if we have arranged the columns accordingly. Let's say to see which is above Philippine average in general, or top 5 regions, for instance. The next one is the COVID-19 chart in Singapore, which contains a lot of elements, making the chart a little confusing. If the goal here is to compare discharged patients over time, putting it in the same chart with new cases makes the chart cluttered. Or if the goal is to check the proportion of discharged patients, this may not be the right chart. So we will talk about how to navigate through these kinds of questions, what makes up a poor data story, and some tips on how to create an effective one. Now we'll dive into telling an effective data story through a compelling narrative. To do this, first we need to understand the context. And these are some of the questions that you may want to ask yourself when understanding the context of what we are doing. First, who are the audience? What are their biases? What keeps them motivated? It is important to know who will possibly see your data story. That way, you can somehow tailor fit the insights in a manner that will benefit them more. Next, what is a successful outcome? Do you intend to influence your audience to act upon something? Or are you just exploring the data and informing them? You have to be clear on what you need to achieve from this. This can also be a good reference when you will do it again in the future. Lastly, where did the data come from? Oftentimes, data would come from various sources. It may be from a system or a database where you extracted or downloaded the data. Or it can be from a colleague or a client, or maybe you collected the data yourself. There will be times when your audience would ask about this, and it is important that you know your data source and how credible it is, because this will help you establish the reliability of your data story and your credibility as an analyst as well. Second point in building a good narrative, choose appropriate visuals and eliminate clutters. In the previous lessons, we have learned how to choose visuals depending on the data, right? So ask yourself, are all elements necessary? Well, if not, we may remove unnecessary elements. Afterwards, check if the cleaner version is still conveying the message that you want to send across. Let us look at this example. So from the original chart, the grid lines were removed and the month was shortened to 3 characters and straightened horizontally to make it more readable. Actually, these 2 steps alone made the chart a lot clutter-free. It is usual to remove grid lines, especially if it did not guide us to the important axis. We can also refer to the Gestalt principles of visual perception in fixing our visuals. This came from the theories of visual perception, and it attempts to describe how people organize visual elements into groups when certain principles are applied. First principle is the principle of proximity. This tells us that our brain tends to group things together when they are closer to each other. Here we see that this whole block of dots on the left is perceived as one whole group because dots have equal spaces in between, while this one on the right is perceived as 3 groups because there are wider spaces between the second and third column of dots and between the fourth and fifth columns. Our brain tells us that these wider spaces are dividers, dividing the block into 3, while those closer to each other belong to one group. Now going back to our chart, the original chart, and if we apply the principle of proximity here, we can move the legends closer to the chart itself so that it will be easy to identify which is for which. It will save time to consume this chart if the labels are closer to the actual lines or bars. Next principle is the principle of similarity. Our brain tends to group things together when they are similar to each other. Now looking at our example, we are grouping the first object in rows because rows have the same colors, while the one in the middle is grouped vertically because of the similarity of colors as well. In the rightmost figure, group this vertically because those elements lined up vertically have the same shapes. Now that's how the principle of similarity works. Applying this to our chart, we can change the color of the labels to the same color of the lines so we can easily identify them as similar, that they belong to one group. Next, we have the principle of enclosure. Now this means that we tend to group things together when they are enclosed in a space. For example, here, without the green box, this can be perceived as just one block of dots. But when we enclose the second row with the green box, the second row is seen as one group now. Applying this principle to our chart, boxing the April data, our attention will be drawn easily to the boxed information. And adding some insights there, it will lead your audience to where you want them to focus on. Next one is the principle of continuity. If you will look at the left chart, you may see this as random categories just presented as is. It is actually hard to draw insights here. While on the right side, data is arranged in a continuous manner, and our attention will follow this continuous line that it produces. It is easier to picture the situation this way. It is also advisable to sort your data accordingly, let's say in ascending or descending manner. Although when there are date and time component, the sorting of data should ideally be chronological. This is how the principle of continuity works. Third tip in creating a compelling narrative is to always try to draw attention to what you want your audience to focus on. Usually in a data story, you would want your audience to focus on one important thing. Well, be intentional with the use of colors. For example, in industry practice, red is used as a negative indicator, like for decrease or decline. On the other hand, green is used to indicate positive movement. If your company or client has color branding, use the color contrast smartly without violating branding rules. Well, this is an example of using colors to highlight insights on the chart, which looks so different from the original one. Usually, all other things are grayed out, and the only colored ones are those parts of the insights. This will lead your audience attention to the important things. If you want your audience to focus on the wrong items issue, you will gray out everything else and make the line for wrong item issue shine. First thing that the audience would notice will be the colored line. While on the other hand, the one on the right, all lines are grayed out and the month of April is enclosed in a red space. Maybe here April is the peak of operations and it has to be highlighted. Or maybe it has the highest issues across all months and they have to focus on this. So this is how we use colors in our charts. Make your insights visible. Fourth tip, think like a designer. After visuals, there should be insights. So these are some of the questions that you may want to ask yourself. Are my insights clear? Did I use simple words? Do not complicate your insights. As much as possible, try to write it in a manner that can be easily understood by people with various technical expertise. These are some of the best practices in generating insights. Number 1, describe trends, outstanding features in the charts, can be your essential statistics or some outliers. You can put callouts within the charts to emphasize the points that you are highlighting. Next, include a time reference if applicable. When you have a time component in the data, you may also check if you can draw something out of the time points. Let's say in June 2022 or in the first quarter of 2021, then you will tell something about what happened there. Number 3, look at the bigger context. If, for example, you know some relevant external information which may not be featured in your data and will help in the context of the results, then you may add those. It can make your insights a lot stronger. Going back to the example earlier, here we know that the attendance for April was relatively low, so we can add that as insights. People can picture that, okay, reasons why we have many issues is because attendance was down by this much. So, yeah, be resourceful in picking other useful information. Next, it is important to understand what is the impact of your analysis. Try to know whether your results are good news or bad news because this can entirely change your narrative. So you can also change the scripting of your insights. For example, you can make it sound more neutral or more convincing. Or you can manage the order of your results. Say you will put the good news first, bad news will come later, and then tell them what they need to do. This will also boil down to understanding the audience. Number 5, choose simple words. Again, do not complicate your insights as much as possible. And last but not the least, if there are actions needed to be done based on the results, highlight your recommendations. It is important to tell them what do they need to do moving forward. This is something that they can take away from these results. Okay, so to sum it up, a good data story, aside from data and visuals, it must have a compelling narrative. The things to remember when building your narrative: number 1, understand the context. 2, choose appropriate visuals and eliminate clutters. 3, draw attention to what you want your audience to focus on. And number 4, think like a designer. That's about it. I hope you will be able to apply these in your data story exercises. In this video, we will try to apply what we have learned into practice, but first, let us recall what we have learned. You should be able to apply the key principles of visual perception, choose appropriate visuals and eliminate clutters, think like a designer, and consider the context in order to create a compelling and precise data story. For this exercise, we will use our call center dataset. I have already pre-processed this file. Lookups have been made and the dates have been fixed. There are also newly added columns here. Okay, so for this task, the first question was show volume trend and give some insights. So the first question that we may want to ask is, why are we doing this? Who will benefit from this? Who are our audience, right? Let's say you found out that this will be used by workforce management, and the goal is to improve customer satisfaction. I have tried to explore the average volume per day. So this is the pivot table for our days of the month, and then the average volume of calls, and this is our chart. In this chart, it is clearly seen that there is kind of a cyclical pattern here, but it's not clear which days. It's we have days with relatively high volume here, right? So just to be just to have a clear picture of how it looks like, I added a new metric here, which is the day of the week. So um, visualizing the chart in weeks instead of days. And here, yes, it is seen indeed that in Fridays and Saturdays, we have relatively higher volume. And as you can see here, another line was added, which is the queue time, right? Because this is happening in any business operations that when you have um, higher number of transactions, then the queue time will be longer. So it is just describing what is happening in our data here. So this is a combination chart. We have a line for the average queue time per day as well, day of the week as well here. This is actually a good visual already because we have managed to describe the trend per day, right, in average for the entire data set. Although uh, it's a little bit cluttered still, so we have created another chart here, just improving the original one that we have created here. So this is the improved version, and the insight is again also describing the statistics. So the average volume for Fridays and Saturdays is 32% higher than the average volume of the other days, stretching the average waiting time to 1 minute or 20 seconds longer than the average. So here we are trying to use the principles of visual perception that we have learned, um, putting the labels closer to the line and the bars, and using colors for the things that we want to highlight. If you will notice, even on the insides, the colors of some important uh, metrics inside your text is also the same as the colors of the charts, the lines, and the labels. So the next question can be, where is the customer satisfaction metric in this data story? Because again, the goal is to help improve customer satisfaction. So it will be a little hard to understand if we don't show that metric in our results, right? So we will try to add customer satisfaction, but before that, this is another visualization for the number of transactions or the calls handled and the average queue time, just to prove some inference that the more transactions that we have, the longer the queue time will be. So it is indeed showing the same pattern, right? So per day, this is on day-to-day basis, and just um, show the average number of transactions and the average queue time. Now this is the chart where we have added customer satisfaction. Okay. The reason why we did not include customer satisfaction in the beginning is because we're just trying to check how our data looks like first. Because by industry standards, we know that um, customer satisfaction is affected by um, the average queue time, but the volume, since the first question in our task is to show the volume is not necessarily related to customer satisfaction, right? We just have to follow that train of thought first. Like we will show the volume, we will show another metric that is connected to the volume, and try to show that it is indeed related to the volume, and then show another metric, which is the customer satisfaction. So this is our transaction count average, and then this is the queue time or the waiting time, right? And then we have added customer satisfaction here, and this is the chart for that. We can see here that the customer satisfaction on Fridays and Saturdays are relatively lower as well when your queue time is higher. So we can add this to this chart, right? This is the chart with customer satisfaction, and just fix the labels a little bit. And also we have changed the insights, because the first one we had here was describing the average waiting time. Now here we are already describing customer satisfaction. So the average volume for Fridays and Saturdays is 32% higher than the average volume of the other days, pulling down the customer satisfaction rating from 6.5 to 7.9 on other days, cooling down the customer satisfaction rating to 6.5 from 7.9 average on other days. So this is the green line for customer satisfaction now, and the average waiting time is here, and the volume is still here. All right. So I think here we have already described what happens in our customer satisfaction, and the volume is also here, which is what is being asked in the beginning, right? But again, we have also learned that if you have some recommendations, try to put it on the onset, right? Because it will be more beneficial to your audience to know what they need to do out of this. So I just also added another thing here that instead of describing our customer satisfaction rating, we can actually tell them something like this. Customers are less satisfied on Fridays and Saturdays. That's a very strong statement. And then you will prove that, or you will back it up with data. With a 32% increase in call volume, here comes the action part. We need to allocate more people during Fridays and Saturdays to handle more calls. This is a different um, kind of data story because here you are already telling your audience what to do. The first two are okay, but I think the third one will spark more action. After they will see this, of course, it will spark some, discussion on what to do next. And again, that is the goal of why are we doing data story like this. All right, that's about it. Feel free to explore some other metrics if you want to try to use this data set further. You can try other metrics like probably average handling time, although handling time is not necessarily related to customer satisfaction because it still depends on how the call went, right? Or probably you can explore maybe product ID depending on which type of product the customer is inquiring about or reaching out about. Maybe there would be different stories here. So yeah, you can also explore other metrics like average handling time or product ID and try to apply the principles that we have learned in a different cut of data. And probably can generate more insightful information here. So that's it. It concludes our lesson. Thank you, and I hope you enjoyed learning Excel.